I want to continue on with our look at Kubernetes. And so what we know is we know about pods, we know about replica sets, and we know about deployments. Now, in real life, the only thing you would really deal with are deployments. You wouldn't create replica sets kind of in isolation. So that's really what happens in practice. But of course, we know that deployments uh, create a replica set, and a replica set obviously creates pods. So that's where we left it off. So if we fast forward to here, and we looked at rollout and rollback. So if I sort of create where we left off last week. And so the deployment that we had was this one here, where we created a replica set of two pods, and the spec for the pods were just Nginx images, an Nginx image. And you do need to become comfortable with these manifest files, which is kind of your access point. So if I check what my status is in terms of pods, I have one pod. This is the pod that was created by this manifest up here, uh, this one here. Again, you wouldn't typically write manifest just to create one pod, but that's okay. So we leave that pod up and running, and we will apply, as the term goes, we'll apply this deployment manifest. So let's do that. What number is it? It's 03. Ceph. Okay, so there's our two replicas. And, if we want to increase the number of replicas, we could do it from the command line, but the simplest way to do it is to go into the manifest file. So if I change this to, let's say, 4, and simply rerun the apply command, I now have 4 replicas. Do I? 1, 2, 3, 4. Yeah, 4 replicas running. And of course, I have a replica set. RS is short for replica set. And I have a deployment. Yeah, I'm just going to scale that down to 2 again. You can also, so I'm doing the scaling here kind of almost manually by editing the manifest file, but you can define a scaling policy. So for example, the policy might say if the number of requests per second for a particular type of pod, then scale up the replica set by however number of pods you want. So you can automate that, and it would scale down then when the frequency of requests decrease. Okay, so that's pods, replica sets, and deployments. The next resource is called a service. And so where services come into play is I'm posing the kind of question here, how do pods communicate with one another? So typically, for example, you might have, well, let's talk about deployments. You might have a deployment for a database, and you might have a separate deployment for a web API. But the pods in the web API would need to communicate with typically there might be only one pod in the database deployment. So how do the API pods, how do they refer to the database pod? Um, and the problem is, of course, that similarly you might have a deployment for the UI part of an application and a deployment for the API part of an application. And equally, the UI pods need to communicate with the API pods. Now, the problem with pods, as we know, is that their IP addresses are not static, they're dynamic. Whenever a pod is deleted or crashes, Kubernetes automatically recreates that pod and therefore gives it a new IP address. So we can't use IP addresses to facilitate that communication. I'm also mentioning here, for example, when you do a rollout and rollback, that also internally that kind of deletes and recreates pods. So there's lots of scenarios where pods need to be recreated, and so their IP addresses are constantly changing. So we can't use pod IPs, and this is where services come in. And so the way you kind of view a service is sort of an interface to a set of pods, where the set of pods represent a deployment. Now, I'm showing the pods here as being almost on one node, but as we know, when we create a deployment, the pods are typically scattered over a number of worker nodes. But that doesn't really matter from the service point of view. The service is still an interface essentially an interface to a deployment, but more generally, it's an interface to a collection of pods. So a service is just another resource, just like a pod is a resource, and a replica set is a resource, and a deployment is a resource. A service is another type of resource. So services abstract a set of pods. Uh, a service is also assigned an IP address, but in this case, that IP address is static, and that's what we like. So now it means that when a pod, let's say a pod in a UI deployment, when it wants to communicate with a pod in the API deployment, it will use the service of that API to get at the particular pod. So anyway, these services are assigned static IP address. Um, uh, we know that pods are assigned to nodes, but a service is not assigned to a node as such. A service is kind of a cluster-wide resource, whereas pods are node-specific. That's okay. And a service also automatically it load balances between the pods that it's kind of managing or interfacing to. So as requests are hitting a particular service, the service will direct those requests in a load balanced way across the various pods that it is kind of in charge of, if you like. And that's kind of out of the box, this load balancing feature. Now, there are four types of services, but really the only ones that we're interested in are the what's called a cluster IP service, and also we will look at the ingress service. I'll briefly talk about the other two and what their disadvantages are really. So first of all, we look at this idea of a cluster IP service. And just like every other resource in Kubernetes, services also are created by means of a manifest file. So I've got a manifest file here for a service for my Nginx deployment. Okay, so I've just created the Nginx deployment. So I've got two pods now running for that deployment. And I want to create a service as a kind of an interface to those two pods. So this is what a service manifest looks like. It has the exact same structure as all the other manifests. It has an API version property. And you might remember from last week, how do we find the value for this property? You might remember the way we go about it is, and you get to know these after a while without having to kind of look them up. But if we go OC API resource, and we'll just grep service. And the one that we're in, there's a couple of resources that have service in their name, but the one that we're interested in is this one here. So a service, let's see, SVC is the short name for service. Its API version is just V1, and the kind is service. Okay, so back to our manifest file. The API version is V1. The kind is service. In terms of metadata, uh, the name part of metadata is whatever you want it to be. I've called it that. We could put labels in here as well, but we don't tend to for services, but you can if you want to. And then we have the spec for a service. Now, a service, as we know now, is it's going to refer to a set of pods. And the way we specify, well, what pods should it relate to is by means of this selector property. We use this selector property as well when we were talking about deployments. So the selector property will list the labels of the pods that it's interested in. So it looks like that we are only interested, this service, sorry, is only interested in pods that have a label key called app and a label value called Nginx pod. Now, if I go back to, just leave this file open. If I go back to our deployment for Nginx, then for the actual pods themselves, then we said here, look, the template for the pods of this deployment in terms of the labels associated with them. Each pod will have a label called app, and the name or the value for that label is Nginx pod. So you might remember from last week, that means now that all of the pods that this deployment, we're looking at the deployment at the moment, all of the pods that this deployment creates, each of those pods will have this label associated with them. And there can be other labels as well. And my service is interested in these particular pods. So back to my service. So the selector is really important, and we've mentioned that before. Okay, so this is specifying the pods. And then what we're doing here in terms of ports is we're associating a port of the service with a port of the pod. So the service is essentially going to be listening on port 8081, and that's going to be mapped to port 80 of my pod. And hopefully port 80 in the pod is linked to the actual application that's running inside in the container of that pod, which it is in our case. Nginx is listening on port 80. So whenever the upshot of all this means that whenever we want to send a request to any one of our Nginx pods, then we can send it to this service and specify the service's IP address, and it's going to get a static IP address. And specifically, we're going to be sending the request to port 8081 of the service, and the service will then redirect that request to port 80 of one of the pods that it's in charge of, if you like. So just like every other manifest, if we now go, first of all, we'll check, do we have any services currently running? SVC for short. I could type out get OC get service, but so we don't have any services. So if I now apply this, yeah, and so my service seems to be okay. Now, a service gets a static IP address, but that's what cluster IP is here. This is the IP address of the service. When it's a cluster IP, that means it's only accessible within the cluster, which is the same for the IP address of pods. So there is that. I didn't highlight that maybe in the slides. If I just go back to the slides for a second. They're assigned an IP address. I didn't say it there actually. Well, I say it somewhere in the slides, but I'm telling you now anyway, that the IP address it's still a private IP address that's assigned to a cluster IP service instance. Back to my manifest. The other thing I didn't specify or I didn't highlight here within the service manifest is this property here, type equals cluster IP, because as the slides are telling us, there are different types of services. Yeah, I'm jumping around a lot now, sorry, but if I go back to here, like we said, look, we're saying here that there are essentially four types of services. And in our manifest file, I'm just saying that this manifest file is for the kind service, but what type of service do you want to create? And so here we're saying it's a cluster IP type service. So a service always gets an IP address, and here is the IP address, the cluster IP address for my service, but that will remain static. Its type is that. That's okay. This service does not have an external IP. Some of the services do, and we'll talk about that in a while. And the service is listing on port 8081. If you want to find out the pods that this service is load balancing over, then there's a command called OC get endpoints. And you just give the name of the service, which is this part here. So if I hit return, what it's giving me here are the IP addresses of the pods that are linked to this service. Yeah, um, that's fine. And if we checked the IP addresses of our two pods, what pods? These two pods here, and you know how to do that. Are we getting it there? If I do a minus O wide, actually, minus O wide, then let's see. Um, yeah, so let's see. So 10.138.1.250, which is that one there. Okay. And it's port 80, which is fine. So let's get endpoints. It's keeping track of the IPs of the pods. And if I did delete, if I just manually kill one of these pods, we know it's going to be recreated because this pod is linked to a replica set, which is linked to a deployment. It'll give it a new IP address when it recreates it, but it'll update this as well. And all of that is being done behind the scenes. And you might remember all of the information about the state of your cluster is stored in that etcd kind of database. Okay, so back to our slides. So we've created our service and we've checked to see that the service is there. We also checked the endpoints, that's fine. Services IP, oh yeah, that's where I say it. Service IPs are private, they're only valid within the cluster. So if I try, let's suppose this was the IP, the cluster IP that was assigned to my service. If I try and do a curl from the command line to that IP address and to port 8081, it's not going to work because this only makes sense within the cluster. However, if I go into any pod, right, it doesn't have to be one of the pods that the service is linked to, but if I go into any pod in the cluster and I try and do a curl to the IP address of the service, then that will work. So let's prove that. So if I go into, let's say, this pod here, which isn't it's completely separate from um, this deployment and the service. So let's do that. Just going to grab that name. And I also need the IP address. Let's see. Let's just grab this. And also I want to grab this. Okay, so we're going into that. And if we do a curl, is curl installed? I hope it is now. Curl to this side. Sorry, not that. Curl to this. And port 8081. Then what I should get back is the home page of the Nginx web server. And I don't. Okay, I need to install curl. Now, let's see. How do I do that? I'll have to get that from the lab, actually. Should probably have done this beforehand. So what's going wrong here now? Uh-oh, curl. Probably would have run. I didn't spot that error anyway. Okay, so I'm getting back the home page. Am I getting? Yeah, I'm getting back the home page from one of the pods. Okay, and that was by sending a curl request to the service. Of course, I could send a curl request to one of the pods as well, and that would work obviously, but we don't like doing that. We prefer to deal with services. Now, as well, okay, the IP address of a service is static, but you know, it would be nicer if we could refer to the service by means of some sort of domain name, which is arguably, more developer friendly. And it turns out that we can. We can send a curl request to where this part here is essentially the name of the service, but the service name becomes the domain name for that service as well. Um, and so what happens behind the scenes is when you send a curl request from well inside this pod, or not, it doesn't really have to be curl. Whenever you use this URL within our cluster, then what Kubernetes will do is it will take the service, take this domain name part, it'll essentially go back to its XCD and do a domain name resolution. It'll kind of find what is the IP address correlating to this domain name. Yeah. And so let's prove that. So if I go curl Now, in my case as well, the service name um, was Nginx service. If I go back to here, the service name is Nginx service. You can see there. So that should match up, and it's port 8081 that the service is listening on. And again, we're getting back from one of the pods. We don't really know which of the pods, but one of the pods is returning back its homepage. So that's this idea of I'm saying Kubernetes supports domain name resolution. And it's also kind of referred to as service discovery. It will look at this here, and it'll look at all of the various services that have been implemented in the Kubernetes cluster, and we know what a service is now. Finds the matching service, and within that etcd database, it will have the IP address, current IP address for that service, which is static, as I've said. So what have I proven? I've proven that one pod can communicate with another pod by means of the latter's service. We can use port forwarding with services as well. So if we just quickly illustrate that, so we'll come out of this terminal session. And if I go OC port forwarding, and I want to map port 8081. Sorry, no, I want to map, let's say, port 3000 of my host machine to port 8081, which is the service port. And here I've got to specify, it's not a pod in this case, it's a service. Now I can use the short name or the long name. So svc / Nginx service. And in my browser, localhost 3000. Okay, I'm getting, again, this is being served up by one of the pods. Sorry, yeah, it's being served up by one of the pods, but it's coming back through the service. So the request is really going to the service because I have linked port 3000 on my host machine. I've linked that to port 8081 of the service. So the request is going from my browser to this service, and then from the service to one of the pods. The pod is responding, and it's coming back the same route, and I'm getting this here. Okay. We said that a service load balances between the pods that are its endpoints. So we have two pods linked to our Nginx service. So what I'm actually showing you here is just a simple way of proving that there is load balancing going on. So first of all, I'm starting up a terminal session in any pod that you want to. I'll use my Nginx pod 1 again. And all I'm doing here is just I'm sort of typing in manually a script at the command line of the pod that I'm execing into. So what I'm doing, I mean, it's fairly simple as to what it's doing. I've just got a loop that's going to loop for 20 iterations, and I'm sending a curl request to my service. I'm just incrementing the counter. So this is going to generate 20 requests to my service. And what I'm doing down here then is I'm actually streaming the logs of one of my pods, but I'll actually do it for both of the pods. And so what we should see in the logs is that roughly 10 of the requests will go to one pod and the rest will go to the other pod. In other words, it's load balancing. So let's set up this simple little test case. So again, let's kill the port forwarding. Again, I'll exec into, not, okay, it's just purely coincidence that the pod I'm execing into is actually also running Nginx. It doesn't have to be. I'm sure you gather that. Okay, so let's go into that. And I'm going to open a separate terminal. And I want to, let's see, OC get pods. And I want to stream the logs of these two pods. So OC logs. Grab this one. The minus F at the end means that you want to stream them. So if I hit return, okay, so these logs, some of them actually related to requests that I triggered to this pod when I was demoing the curling to the Nginx service there earlier on. So if we just create a few blank lines, but it's waiting here now. It's still streaming the logs from this particular pod. So that's going to stay there. Let's open up a third terminal and we'll do the exact same, but for the other pod. So OC logs again. No, need to first of all go OC get pods. Grab the second one. Create a few blank lines. Okay, so we now have three terminals open. Two of them are streaming the logs from my two pods. And if I go back to, which one is it? I think let's hope it's this one. Yeah, so what I'm going to do now is I'm going to grab my script, which I have here for convenience. Where is it? There it is. I just grab this. Now, when I hit return here, it's going to send 20 requests to my service. So let's do that. And okay, we got back 20 responses, so that's fine. That's the um, 20 web pages from my 20 requests. But if I go into the log streaming and I'll pick any one of them. Yikes, where are we? What happened there now? Got too many terminals going on here now, actually, it looks like. Okay, there's one of them. Okay, so it started here. And can we count them? Let's pull this up a little bit. Just make it a little bit smaller as well. See if we can count them. So what have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, hang on. That doesn't look right. Do they all go to one of them? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, there's 13. And so it should be 7 in the other one. I don't know where the other one is though. Let's see, is it here? Uh, 1, 2, 3, 4, 5, 6, 7. Yeah, good. So it sent seven of the requests to one of the pods and 13 to the other pods. So, okay, it's not a 50-50 split, but it's certainly some element of load balancing going on there between the two pods. So the service does seem to be doing load balancing first, and it's fairly primitive type of load balancing. It's not very sophisticated, and I don't think we can change the load balancing algorithm. That's not that facility isn't available to us. Okay, where are we on time? That's fine. Uh, right. So that's cluster IP, the cluster IP service type. And if we go back to this slide here, so we've looked at that. I'll just briefly talk about these two, but we're not going to use them. And there are reasons for that. So let's talk about the node port service type first. Uh, you would tend to use the node, well, sorry, the first thing about node port service type is that it is accessible outside of the cluster. The cluster IP type that we've just been looking at, that is not accessible outside of the cluster, other than doing port forwarding, but that's not much usually. That's okay. Port forwarding is fine for debugging, but other than that, it's not much use. So cluster IP service is not accessible outside of the cluster. A node port service is accessible outside of the cluster. And the way it works is, so let's suppose we've got a deployment here consisting of two pods, and we've got a service. And in this case, the service is of type node port. Now, when you create the service, and I'll show you the manifest file in a moment, it's very like the manifest file for a cluster IP service, but there's an additional piece of information that you include in a node port service manifest, and it is that you specify a port uh, that you want to expose this service to, where that port will be linked to the node, nodes actually, plural, the worker nodes of your cluster. So we have three worker nodes, for example, in our cluster. And if we create a node port service, and let's supposing we pick port uh, three, I think it's up in the 30,000 brackets. The port numbers that you pick, the node ports that you pick have to be up in there's a particular range, but it's up around the 30,000 number range anyway. Let's suppose we pick port 30,000 as being our node port number. What that means is that port 30,000 of the node now, of each of our worker nodes, that port number is linked to this particular service. And so if we know the IP address of the node, um, we can send a request to any one of these pods by using the IP address of the node and the particular node port number that we picked. Let's say it's 30,000. Now, this only works, number one, if you actually do have access to the IP addresses of the nodes that make up your Kubernetes cluster. And in our case, we don't. But in many cases, in some cases, you would. And so these node port services now would allow us to access a service within our cluster, access it externally by using the IP address of any one of the worker nodes and the particular node port number that was specified for our particular service. If I just switch over to VS Code, and sticking with our Nginx deployment example, if you see this, yeah, this one here. So this is a manifest file. What kind? It's a service manifest, but the type of manifest is node port. Everything else is pretty much the same as before, right? We're specifying, um, we're selecting a particular service. Well, here I should really put, I should put Nginx service as being the name. Maybe let's just do that. Ports are the same as before, but there is a third port here now that we're specifying, and this third port is what we're calling the node port. And this is specifying the port number of your worker nodes that you're essentially opening up for external access. And I've picked 30,000. So let me just deploy this service. I'm going to kill off some of my terminals now because there's too much going on here. Now I better give this service a different name. Let's call it Nginx NP for node port. Yeah, and everything else. Sorry, this should be Nginx pod. I might just delete the other service actually, so it doesn't conflict. if I now apply this service specification, okay, there's my service. Here's its type, node port. It does get a cluster IP, that's okay. Now, it should get an external IP here, but because we do not have access to you need to have access to the worker nodes of your cluster, and those worker nodes have to have a public IP address assigned to them, and they don't in our case. Okay, but if they did, then you would have the external IPs of I think you can use any of the worker nodes, or maybe it nominates one of the worker nodes, and you'd have the external IP of that node here. And having the external IP and using the node port that was selected, that's what we're being told here really by this 30,000. Then, as I said, we could essentially send a curl request to this IP address colon 30,000, and that would uh, find its way to one of our pods via this service here. Okay, but I can't demonstrate that. The thing though is that, the problem with this node port, it's fine if you're debugging, and that's really what it's mainly used for. You would not use a node port service type in production because it's insecure, right? You're opening up a port of your worker nodes, a TCP port of your worker nodes, so that's a security risk, obviously. Uh, and also, I'm saying here it's unstable because if just like with pods, if pods go down, then Kubernetes will recreate it. Equally, if a worker node crashes, then Kubernetes will recreate that worker node or reboot it. But it's going to give it a different IP address as well. And so that now means that your node port service is kind of out of date. It will update itself internally, but of course, anybody who's using the IP address to access the node port service, they have to be informed that the IP address of the node has now changed. Okay, so it's unstable in that sense. So as I said, it's mainly used, this service type is mainly used um, as a debugging aid. And it means we no longer have to do port forwarding. That's probably an advantage of it. There's no need for port forwarding now because we can actually access the service externally. The third type of service is called a load balancer service. So I don't have an example of that, but essentially what you would do is you would change the type here from node port, change it to load balancer. There's one or two other changes that you'd have to make down here as well. Okay. Now, uh, what happens here is, so let's supposing we've got two deployments. And just a screenshot is saying, let's supposing this is deployment for a to-do application user interface, and this is the deployment for your to-do applications web API, kind of REST API. Okay. And okay, so there are two deployments, and they are related to one another, but that's okay. We've got a service for each of these deployments. These services now are of type load balancer, but they're still just services. So they do get a cluster IP, and if this pod wants to talk to one of these pods, it can do it via uh, this service here, because this does have a cluster IP address. So we saw how that works. But it's really what we're really on about here is trying to access these services externally. Now, if this is created as a load balancer service type, then what you need to do as well is create a load balancer resource up in the cloud. So let's supposing we were using the AWS cloud provider. We would have to go into AWS, log into our AWS account, create an EC2 load balancer instance up there, and link that to our service. Similarly, for this one, we would have to create a second EC2 load balancer, if it's AWS you're using, and link that load balancer to this. And that's all doable, right? Now, these load balancers, these have public IP addresses. And if they do have public IP addresses, we can now send a request to the IP address of either of these load balancers, specify a port number, and this load balancer will redirect the request to your cluster, to your Kubernetes cluster. When Kubernetes receives the request, it will know to send it to the particular internal service. And once it gets there, the service takes care of uh, sending the request to one of the pods using the load balancing approach. So there's load balancing going on here. Okay, there isn't load balancing going on here because there's a kind of a one-to-one relationship between this load balancer and this internal Kubernetes service, and similarly over here. Um, so the downside of this, I know we're using load balancer now, and we're using load balancer in relation to the service type, and we're using load balancer up here as a kind of an external cloud resource, but so be it. So the overall advantage of this service type is that we can now access it externally via the cloud load balancers. So that's good. No need for port forwarding. And we're not exposing any ports of our worker nodes, so it has that advantage as well. So lots of advantages over the node port approach. The main disadvantage is these things cost money to run. And you have to have a load, let's stick with EC2, for example. You have to have an EC2 load balancer for each of your internal services. You can't have one load balancer directing to different services. And that's the main disadvantage. So it becomes a very costly approach towards having external access to an internal Kubernetes service. These load balancers are expensive. And, in a large organization, you could have dozens, if not hundreds, of services. And if you want to expose all of those externally, then you're paying for dozens, if not hundreds, of load balancers. So that is a big disadvantage of this approach, and consequently, it's hardly ever used. So the disadvantage is you must configure an external load balancer and the cost side of it as well. is a major downside. Just checking my watch. I think I'm going to stop here actually. If I go back to a couple of slides, the fourth and final type of service is the ingress type, and that is used a lot, and we will use it in the labs as well. So the two ones that are mainly used are cluster IP and ingress, maybe node port, but only for debugging purposes, and hardly ever load balancer, unless unless you only have one or two services that you want to expose externally, um, and for whatever reason you don't want to use ingress, then you might use the load balancer type then. But other than that, it's hardly used at all. Right, going back to the website. So you can see there's a lab here that I'd like you to walk through this week. And essentially, it's talking about pods, replica sets, deployments, and services. So everything that we've covered in the lecture so far. Okay, that's it for this morning. I'll just pause in case there are any questions that you have for me so far, or in relation to the assignment. No. Okay, I'll stay online, of course, in case there are any questions as you work your way through this lab, or if there are questions that you have for the assignment that you want to put to me, kind of one-to-one. All right, I'll close down the session at this stage. Talk to you later.